7.2 is about similar polygons. Again, key concept here is about similar polygons. The two polygons are similar if corresponding angles are congruent and the corresponding lengths of the sides are proportional. Okay, so angles congruent, sides proportional. That's just the definition of similar polygons. So you can use that in a number of different ways. What's nice about similarity is it's almost the same as congruency. When we talked before, it's all in the name. So pairs of congruent angles here, when we have triangle MNP is similar, that little sign right there means similar. Okay, to triangle SRT, I can take and I can talk about the angle M being congruent to angle S. Why? Because they match up. Now I could look at the picture, but just look at the name. M and S match. Angle N congruent to angle R. And angle P congruent to angle T. Okay? We're going to talk about the extended proportion. Again, that's going to be 3 proportions out. What sides to what side? Again, it's in the name. MN over SR equals, go to the next one, NP over RT, and then go to the last one, PM, and again I go back to the beginning, PM over TS. And that's your extended ratio. Now, if we want to determine similarity, are the polygons similar? If so, write a similarity statement and give the scale factor. So I'm going to look at is the angles first and foremost. If I look at M and W, yeah, they're congruent because of the one line. J and T congruent because of the 2 lines. U and K are both right angles. And V and L, see how the 3 lines are there? Good. Those are all congruent. So all my angles are congruent. So we're good there. I've got to check to see if the sides are proportional. So step 1, all angles are congruent. So check. Step 2, we're going to talk about are my sides proportional. So let's do JM is 6 over TW, which is 6. That gives me 1. So there's my 1 scale factor. Let's try another side. I get 12 over 6. So JK is 12. TU is 6. That gives me 2. See how these don't match? So they're not similar. Okay, they're not similar there. So let's go to B. Let's look at the angles. Step 1, angle A is congruent to angle D. Good, we're there. We've got the 2 lines in each. Angle C is congruent to angle F. Got the 1 line in each. Perfect. And angle B is congruent to angle E. Again, 3 lines in that. Good, there's step 1. Let's look at step 2. Okay, well, one angle C to A, it's 1 to 3, so let's look at 1 to 3 as F to D. So C to A is 8. F to D is 10, so 8 over 10 equals 4/5, perfect. Okay, let's go to 1 to 3, okay, which is C to B. That's 16 over, and then let's go 1 to 3, which is F to E, which is 20. Punch in my calculator again, reduces to 4/5. Perfect. And then the last one is 2 to 3 is 12 on top over 2 to 3, which is D to E, 15. And again, that also reduces to 4/5. So our scale factor is 4/5. We want to write a similarity statement, so it's triangle, and this matters. ABC is similar to triangle. Again, 2 for A, so 2 for D, 3 for E, and 1 for F, D, E, F. And my scale factor would be 4/5. Problem 3 talks about using similar polygons. ABCD is similar to EFGD. So the 2 figures are similar. So let's set up a proportion here to solve for X and Y. Okay, FG is X. If we look in the FG is in the middle, it matches BC. So FG is X, BC is 7.5. Perfect. Well, what can I use? Well, if I look at the first one is AD, which is this side right here on the left, AD is 9. That's the big one that goes on bottom. We did small over big. And AD matches ED, and ED is the small one here, which is 6. So I'm going to put it over top. Now, how do I solve? Cross multiply. Get 9 times x, which is 9x. and 6 times 7.5 is 45. Go ahead, divide by 9. I get x equals 5. Okay? So that's all we want to do. We want to find the value of x. We could find y much the same way, but we just wanted to find the value of x in that particular problem. Problem 4 talks about a poster is 6 inches high by 10 inches wide. The space allowed is 4 feet high by 8 feet wide. What are the dimensions of the largest poster that would fit? So we want to scale it to be that high. So what we want to do is see if we can scale it exactly. So 4 feet high is 48 inches. 4 feet multiplied by 12 gives me 48 inches. Since it's 48 inches, I'm going to take the 48 inches and let's divide it by the 6 inches high it is. That's going to give me 8. So since it factors evenly, that means I can scale that height exactly by 8. Okay, so I can make it 48 inches high. Perfect. So that fits. So I want to talk about, that's step 1. Can I do it with the width? Well, 8 feet, again, multiplied by 12, you're going to get 96 inches. The poster is 10 inches wide, so 96 divided by 10 is 9.6. That doesn't work because I want it to be there. So we know that we can set up a proportion in step 2 where our 6-inch poster can give us 48 inches. Is perfect. We want to know how big our 10-inch poster can be. Okay, so we're putting the poster on top and we're putting the wall on bottom. Okay, so 6 over 48 equals 10 over 9. Again, cross multiply, we end up with 6x equals 480. Divide by 6, x equals 80 inches. So the biggest it can be is 80 inches. If you want to convert that back to feet, just divide by 12. So our poster size, or it's going to be 48 by inches. 48 inches wide, because we know that, by 80 inches. I'm sorry, 40 inches high by 80 inches wide.